Please subscribe so that you keep up to date, because more tutorials solving past exam questions to assist you will be uploaded. Hello brilliant students who want to succeed. This is a detailed step-by-step explanation of West Africa Senior Secondary Certificate Examination Physics Paper 1 2023 Objective Test. A must-watch before your exams. You have a lot to benefit as you actively watch this video. Super easy physics and mathematics is here to help push your grade to A star. Please kindly like and comment on the video and feel free to ask any question, I will reply you. Thank you for watching. May God bless you guys. Physics Paper 1 2023. Question 1. The instrument used to measure relative humidity is A. Question 2. Which part of the human eye performs the same function as the diaphragm in a lens camera?
That is the iris. B. But let me explain how it functions. So if you have a camera, in this particular camera, this is the aperture of the camera, which is the same thing as the pupil, and then the iris is the same thing as the diaphragm. This is the part that controls the amount of light entering into the eye through the lens. So in dim light, the iris is going to contract so that it will open up the pupil for more light to enter. So that's why you have this yellow portion here. This is the amount of air entering in dim light. But in bright light, what is going to happen is that the iris will cover up the gap in front of the lens to allow limited amount of light to enter, so which is this yellow portion. So the pupil will become smaller, will make a small hole like the diaphragm. So the diaphragm will close up the aperture, the amount of light entering. So like in this case here, you have the gap. So this gap here is the aperture or the pupil. Then you have bright amount of light coming in. The light is too bright. So what is going to happen is that the iris will cover up the gap so that the amount of air entering will reduce. So that is how it operates. So this is for bright light, and then the iris and the diaphragm behave like the closing up process.
Question 3. An electron moves from an energy level of -8.6 electron volts to another level of -3.5 electron volts. Determine the frequency of the absorbed radiation.
So the electron moves from this energy level to this energy level. So with that, we can calculate the difference in the energy level is equal to the energy of the radiation that is released, which is the energy of the radiation is the product of the Planck constant h multiplied by the frequency of the radiation. So with that, make frequency subject of formula, substituting. Then remember that 1 electron volt is equal to 1.6 times 10 raised by -19 joule. So making that so the frequency of the radiation is going to be 1.24 times 10 raised to the power 5. So A is the answer to this question.
Question 4. A ball of mass 0.8 kilograms is dropped from a height h just before hitting the ground. Its velocity is 5 meters per second. Determine h.
So we have the ball. Drop it. The ball is from the height of h, so it's dropped, and then at this height the gravitational potential energy is converted to kinetic energy as it falls. And with that, so when it falls, what will be the velocity with which it will strike the ground? We're given that the velocity with which it strikes the ground is 5 meters per second. So substituting with this understanding that the total gravitational potential energy is equal to the kinetic potential energy of the ball after falling. So substituting, we discover that on both sides the mass of the object is the same, so the mass can go off. Then the height is equal to v squared divided by 2 multiply acceleration due to gravity. That gives the height of 1.25 meters.
Question 5. Which of the following statements about latent heat are correct? I. When ice melts, latent heat is absorbed. 2. When water freezes, latent heat is given off. 3. When water evaporates, latent heat is absorbed. 4. When water vapor condenses, latent heat is absorbed.
So when heat is added to ice, latent heat is absorbed in order for it to melt into water, and then for water to boil to form steam, latent heat is absorbed, and then when steam condenses, latent heat is released for it to form water. Then when water freezes, latent heat is released for it to form, for the water to solidify. So 1 is correct, 2 is correct, 3 is correct, the 4th one is wrong. When water vapor condenses, latent heat is absorbed? No, latent heat is released. So the correct answer is 1, 2, and 3 only.
Question 6. Increasing the frequency of a sound wave produces a sound with.
So let's look at some basic facts we need to learn. Increasing the frequency of sound, frequency and amplitude. Amplitude affects the loudness of sound, while frequency affects the pitch of the sound. So the higher the frequency, the higher the pitch. The lower the frequency, the lower the pitch of the sound. While a larger amplitude will produce a loud sound, while a low amplitude will produce a quiet sound. So increasing the frequency will produce a higher pitch sound, so which is C.
Question 7. Which of the following diagrams correctly illustrates the mode of oscillation of air in a tube? For the first overtone,
A is the first fundamental note or the basic note, the basic vibration mode for open tube. B is the second harmonic or the first overtone for open tube, while C is the first fundamental note for that of a vibrating string, while this too is the second overtone or the third harmonic for a string vibration. So the correct answer here is B.
Question 8. In a mass spectrometer, an ion of charge, Q, and mass, m, moving in a path of radius, r, in a field of flux density, B, has a speed of.
So if you have the magnetic field entering into the paper, then we have an electron that moves in the circular blue path. So moving in that circular blue path, what is going to be the speed of the electron? So the magnetic force is equal to the centripetal force of the electron. So having that, so we are looking for the speed of the electron. So we have speed on both sides v. So eliminating that, so the speed is equal to magnetic field multiplied by the charge of the electron multiplied by the radius of the circular path divided by the mass of the electron. So the answer is C.
Question 9. A sound of frequency 512 Hz reaches a listener 100 m away. If the sound travels in air at standard temperature and pressure, what is its wavelength?
So we know that the wavelength of sound is equal to the speed divided by the frequency. So this is a direct question, but this 100 meter is a distraction. You don't need it. So the answer is B.
Question 10. In the Rutherford scattering experiment, a beam of alpha particles was fired at a thin gold film and few of the particles were deflected considerably. This shows that the nucleus of an atom.
So if we fire this alpha particle at this nucleus, so let's do that. So it's deflected from this. So what does the deflection tell us? Is deflection because there's the alpha particle was repelled by the electronic charge in the nucleus of the atom. So that gives us that equation there, that it is positively charged. The alpha particle is positively charged, and inside the atom, the nucleus of the atom is positively charged, and it is concentrated in a tiny part of the atom. So B is the correct answer to this question.
Question 11. A charge of 10 coulomb is transferred across a potential difference of 220 volt. Determine the work done.
So work done is equal to the charge multiplied by the potential difference. So it's a direct question, substituting. Work done is 2200 joules. D.
Question 12. A solenoid is constructed by winding an insulated copper on a long test tube. A constant direct current is passed through the solenoid. Which of the following actions will not increase the strength of the magnetic field of the solenoid? Inserting A.
If you insert a nickel rod, which is magnetic, is going to increase the current. If you insert a brass rod is a non-magnetic, it is not ferromagnetic, and is not paramagnetic rod. So this is the answer. If you insert a soft iron, it is paramagnetic and also a ferromagnetic material. This will increase the current. Steel rod is also paramagnetic and ferromagnetic, so it will increase the current. So the answer to this question is B.
Question 13. The following statements are advantages of a solid dielectric material between the plates of a capacitor except that.
So let's look at the function of dielectric material between the plate of the capacitor. Option A, it keeps the plate at a fixed separation. That is correct. The diamagnetic material, the maximum potential difference, the capacitor can withstand this increase when a dielectric material is placed between the plates. That is correct. The capacitance of the capacitor of a given dimension is much greater than that of the plate in a vacuum when a dielectric material is placed between the plate. That is correct. It increases the electrical conduction of the capacitor. No, it doesn't. It does not increase the electrical conduction. Dielectric material is an insulator, so it does not allow electron to flow between the plates. So the exception to the actual answer to this question is D.
Question 14. Which of the following statements about a ferromagnetic material is correct?
Attracts non-magnetic material? No. Has low permeability, that is the ability for it to be easily magnetized, that is permeability. It repels other magnetic material? No. It attracts other magnetic material. It has high susceptibility. It doesn't have high susceptibility. Now, susceptibility is the ease with which a material can be easily polarized or ionized. So the actual answer to this question is B.
Question 15. A ball, P, is released from the roof of a building at the same time as another ball, Q, is thrown vertically upward from the base of the building. Which of the following statements is correct?
So what we are looking at, you have this ball P released from the roof, and then another ball is thrown from the bottom. If you look at it, both of them are going to, the one P drop with the acceleration due to gravity, and Q, as it's flying up, is also going to be acted upon with acceleration due to gravity. So the direction of the acceleration due to gravity is always pointing towards the center of the earth, is pointing downward, and the magnitude is +10 for the falling object. But for the object that is being thrown up, the acceleration due to gravity is also going to be 10. The direction is acting downward, but the value is negative because it's decelerating. So let's look at the options. So we have A, the acceleration of P is greater than the acceleration of Q. So I'll just look at the throwing up and the falling of the object. So A, acceleration of P is greater than the acceleration of Q. That is wrong. The acceleration of P is equal to the acceleration of Q, and both are in the same direction. That is the correct answer. The acceleration of P is equal to that of Q, and they are in opposite direction. No, the acceleration is not in opposite direction. Acceleration of P is less than the acceleration. No, it's not less, it is equal. So the correct answer is B.
Question 16. A planet has mass m and radius r. If the universal gravitational constant is g, what is the expression for the escape velocity of an object on the planet?
So let's say this rocket has a mass m and is going to escape with the velocity of v. So what we are going to do here, the work done in moving the rocket out of the earth is equal to, the work done is equal to the kinetic energy of the rocket as it escaped. So this is the expression for the work done, which is force times distance, gravitational force multiplied by the distance r. So that, and then this is the expression for the kinetic energy of the rocket as it fly away. So since the mass of the object is the same, it can be eliminated from both sides, and then you make V sort of formula. So that gives us the answer to the question. So let's launch the rocket. So it flies off with that. So what is going to be the escape velocity? So this is the value of the escape velocity.
Question 17. The specific latent heat of vaporization of lead is 870,000 joules per kilogram. This means that 870,000 joules of thermal energy is required to change.
So we are looking at latent heat of vaporization. So our interest is you want to convert vaporization of lead, that is molten lead. So that is the emphasis there, is in the liquid form, is in the liquid state. So you have to be converted to the vapor state, that is the gaseous state. So molten lead to vapor. So 1 kg, the latent heat of vaporization, is the amount of heat needed to convert 1 kg of liquid to gas at the boiling point. So that means since it is molten lead, so it's a solid that is in the molten state, so the amount of the latent heat of vaporization is the energy needed to convert 1 kg of molten lead to vapor at constant temperature and pressure. So the correct answer is A. This is just a question that tests the definition of latent heat of vaporization.
Question 18. A 100 kilograms device is pulled up a plane inclined at 30 degrees to the horizontal with a force of 1000 Newton. If the coefficient of friction between the device and the surface is 0.25, determine the total force opposing the motion. Take acceleration due to gravity as 10 meters per second squares.
So if you have this object on this inclined plane, the angle of inclination of the inclined plane is 30 degrees, and then the force pulling it up, the green force, is 1000 Newton. Then the weight component that we pull backward against the pulling force, and then we have the friction between the surface and the object on top of the inclined plane. So the red and the black are the opposing force. So if we resolve that, we have the component of the weight is the weight of the object multiplied by the sine of the angle of inclination, while the frictional force is the coefficient of friction multiplied by the weight of the object, then multiplied by the cos of the angle of inclination. So this is the angle of inclination here. So if you substitute your value into that, which is correct, so M substituting, so the total force opposing the motion is 717 approximately. So we have C.
Question 19. Two objects, A and B, accelerate from rest at uniform rates. B accelerates twice as much as A. Compared to A, B travels.
So if you look at this object, so the acceleration of an object is equal to the final velocity, take away the initial velocity, divided by the time of motion. So if we have that, the acceleration of A, of object A, let's call it A, and then from the condition given to us, the acceleration of object B, the red, is 2A, is twice. So substitute, so let's get the equation of motion. So it's U, we are using the second equation of motion. Distance is equal to UT plus half at square, but since the both of objects started from rest, so ut component is removed from it, so we are left with what? Half at square. So if we substitute into that, so the distance traveled by object A is s equals to at square over 2. Then the distance traveled by the object B is going to be, in place of A we have 2a t square over 2. So since we are comparing both of them, so let's divide. So divide the distance traveled by object B by distance traveled by object A. So that brings us to this. So you cancel out. So we are left with 2. So the distance traveled by object B is equal to twice the distance traveled by object A. So the answer is A.
Question 20. The diagram above illustrates a hot metal suspended at the center of a closed uniform box. Thermometers E, F, G, and H are placed in contact with 4 sides of the box. Which of the thermometers would register the highest temperature?
This is a simple question. What you need to do, the understanding of how thermal energy is transferred in air. So because they say that it's placed at the center of the box, so what is inside the box is air that is enclosed. So if you heat up the box, the hot air will move up while the cold air will move down. So among this thermometer, G is going to measure the lowest temperature, and then hot air rises while cold air falls down. So the hot air that will be at the top, so the top of this gas is going to be containing the hot air. So, and this is the reason why in the house, in temperate region, heaters are installed near the floor of the house, and then in tropical region like Nigeria, AC are installed near the roof of the house. So when the AC produces the cold air, then because of the cold air can drop from the top to the floor and keep the entire house cool. But in temperate region, heaters are installed near the floor of the house. So when the heater produces heat, the hot air rises to the top and keep the entire room warm. So the answer to this question is A. So this brings us to the end of the part 1 of this series. I know you are a student that want to excel. Subscribe to Super Easy Physics and Mathematics so you have opportunity to preview other videos when they are uploaded, because other videos will be uploaded to help you perform better in your physics examination.
SEPAM is here to help push your grade to A star. More tutorials solving past exam questions to assist you will be uploaded, so please subscribe to keep up to date. Please kindly like and comment on the video and feel free to ask any question. I will reply you. Thank you for watching.